Okay, so talk me through these. Number one is which shape? The parabola, the parent function would be f of x equals x squared. What's the plus 3 do? Up 3. Up 3. Inside the parentheses is right or left. Up 3, go up and down 1. Draw your parabola. 2, what's your parent function? So the equation would be f of x equals the square root of x. And the graph is the little arc that's pointing towards the right. What's the minus 1 inside? Good. And what's the minus 4 at the end? Down 4. So we go right 1. We go down 4. And then we make our curve point to the right. What's the parent function for 3? Good, absolute value, so f of x equals absolute value of x. The shape is a V. What's the plus 2 inside doing? Left 2 and down 3, good. Questions on those? All right, 4, back to the squared. So f of x equals x squared is our parent function. What's that 1/2 do? Makes it wide. Good. Wide or it's stretched. Okay, something like that would work. Not stretched. Wide or shrunk or compress. It's the official term. Okay. The minus 2 does what? Down 2. So I'd go down 2, and then instead of going up and out 1, I go up and out 2, which makes it wide. Five is getting more on level with what you might see on your test. It's going to be more than one transformation built in. It's going to be several. 5's absolute value of x is your parent function. The negative on the front does what? Upside down. Or over the x. What's the 5 do? Makes it narrow or stretched vertically. What's the minus 1 do? Right 1 plus 2, up 2. So there's a lot happening, okay? Right 1, up 2, upside down and narrow. Instead of going up and out 1, we go up 5 and out 1. And by up, I mean down really, because it's upside down. And then 6, parent function, square root of x. What's the negative inside the square root do? Flips it over the y, God bless you, or points left. What's the plus 3? Up 3. Questions on any of them? So again, just like the homework, which I will not forget to post those solutions, but like the homework, you will also get a graph on your test and you'll have to give the equation. Good? Feeling confident on 1.4? Yes? Okay. All right. We move into 1.5. So this is combining functions. This should have been in both regular and honors. However, honors, we probably went into domain a little bit more than regular. So some of this will be review and some of it will be new. These are all the things we can do with two functions. We can add two functions. So if it says f plus g of x, it means take f of x and add g of x to it. Difference, I can subtract them. So if it says f minus g, that means f of x minus g of x. I can multiply them, f of x times g of x. I can find their quotient or divide them, f of x over g of x. Those we're going to worry about the domain because we're putting things in a denominator. And then the last thing is a combination function or a composite function, which means you take one and you plug it into the other. We tend to call this fog just for short because it's an open dot. You could also have g of f of x. The order matters because the one on the right is what's going to get plugged into the g, or to the one on the left. So this would be g of f of x. We're going to do these with equations and with graphs. You'll be tested on both. We're going to do these with equations, numbers, and graphs, actually. Anybody still copying down? Okay. Example 2 is where we're going. So it says, and there's 4 parts, find f plus g, find f minus g, find f times g, find f over g, and their domain, okay? So before we even get into any of the combining, we're going to find the domains of the original functions. If you use that function, and even if you alter it by making a new function when you combine it, you have to carry down the domain of the original. So if there's a restriction in f of x, every time I use f of x, I have to carry it down. This changes when we get to the open dot. So this changes when we get to f of g and g of f. That's a different rule. But for adding, subtracting, multiplying, and dividing, if there's a restriction in the initial one, we carry it down. So go to A first. Is there a domain restriction on 2 plus x? No, it's all real numbers. Is there a domain restriction on g of x? No, all real numbers. So I don't have to carry anything down. But if you just glance ahead to B, notice that there's square roots there. There will be a domain restriction there, so I have to carry that down. Now we're going to do all the parts. A says add these. 2x plus 1 plus x squared. You literally could leave it like that. You can arrange it if you want, but you could also leave it like that. Now, once I combine them, I have to look again, is there a new domain restriction? So by adding these together, did I create any other restrictions? No, which means the domain of the whole thing is negative infinity to positive infinity. Yeah. No, this is just domain, yeah. The range you're really only going to find from your graph. Yeah. All right, how about B, f minus g? This time we're saying 2x plus 1 minus x squared. Again, I can leave it just like that. Did I introduce any new restriction? No. So domain is still negative infinity to positive infinity. F times g is next. 2x plus 1 times x squared. This time I'm going to multiply it, so distribute the x squared, and I get 2x to the third plus x squared. Did I introduce a new domain restriction? Nope, still negative infinity to positive infinity. And the last one is f over g, 2x plus 1 over x squared. Did I introduce a new domain restriction? Yes, this time we put a variable in the denominator, right? So what is true about that x? It can't equal what? 0. So if there was a domain carried down and this new one, I would combine them both. This is just this new one, which means my domain is negative infinity to 0 and 0 to positive infinity. Questions on this one? All right, go to B. First thing we're going to do is test the domains. I'm actually going to do g of x first, and then we'll do f of x, because g of x is easier than f of x. What's the rule on the square root? Has to be greater than or equal to 0. So x has to be greater than or equal to negative 1. I'm not going to put it in interval notation yet because I'm going to wait to see if there's another one to combine it with. Go to 4 minus x squared. This also has to be greater than or equal to 0. There's an x squared and an inequality there now, so this changes how we do it. If you remember test points, when it's quadratic and inequality, you have to solve it as though it's equals, and then you do your number line and test a point. So I'm going to solve this as though it's equals to 0. I can factor that because it's the difference of two squares. And I get x equals -2 and x equals +2. But it's not just that it can't equal those things. Those are the range that I have to test. It's in every other pattern when it's quadratic, so I only have to plug in one number, and I would pick the easiest in between -2 and 2 is 0. And I'm going to plug that into my initial inequality. So 4 minus 0 squared is greater than or equal to 0, and 4 is greater than or equal to 0. Is that true? Yes. If it's true, that's the range you use. If it's false, you use the other range. Every other is the pattern. So it would either be outside or inside. So the domain restriction here is x has to be greater than or equal to 2, but less than or -2, sorry, but less than or equal to -2, or brackets on these. That means every time I use both f and g, which is every single one of these, I have to carry down both of those. With me so far? This is the hardest part of the whole lesson. Okay, so A says add them. Square root of 4 minus x squared plus square root of 1 minus x, plus x. Can you combine two square roots that are not the same? No, that is it. I'm done with the actual adding part. Now I have to include the two domain restrictions I already got from the beginning, which said the first one from -2 to +2. The second one from -1 to +infinity. These would have been brackets. And I have to pick the overlap, which goes from -1 to +2. And I would look at my new function, the combined function, and see if it adds anything. Really, you're looking to see, like, did it put it in the denominator? That's really what would change it. And that didn't happen. So it's this would be my domain. Yeah?
It doesn't go any farther than that. You don't do to the infinity.
No, because the one on the right was greater than -1, but the one on the left said it had to stop at 2. Okay. So it has to be the overlap. All right, B says subtract these. So 4 minus x squared minus the square root of 1 plus x is the sign is the only difference, which means the domain would also stay the same. We don't have to do it again. C says multiply these. Square root of 4 minus x squared times square root of 1 plus x. That is totally an acceptable answer. You can leave it like that. You can also, because they're both square roots, FOIL them out. But you don't need to do this. It's extra work. I'd get -4 minus 4x minus x squared minus x to the third. Either of these would be acceptable. WebAssign and test. Did I introduce a new restriction? No, so my domain is still -1 to 2. Now the last one says f over g. So square root of 4 minus x squared goes over square root of 1 plus x. You do not need to rationalize that. You can leave it as it is. Did I introduce a new domain restriction? What happened?
The bracket.
Good. I put that square root in the bottom, so now it can no longer equal 0, right? It's just greater than 0, which means the bracket on that -1 becomes a parentheses. The 2 is fine. The 2 came from the numerator. It can still be 0 in the numerator. The bottom is what changed. It now can't equal that -1. Yes?
It's always a bracket unless it's like under square root in the denominator.
Well, it's a bracket if it's an or equal to.
Yeah.
So anything in the denominator would not be, so like even if it just said x can't equal 0, that's a parentheses.
Okay.
Yeah. Anything that says not, so anything in the denominator is going to cause a parentheses.
Okay.
Yeah. Questions. Again, this is the hardest, I think this is the hardest part of the whole lesson. So if you can understand this, yay. If you're still a little shaky on it, it's okay too. But the important thing is that whatever initially is part of your domain from the original functions has to get carried down. And then when you do a combined one, add, subtract, multiply, divide, you also have to check the new one. Again, the rule changed for the f of g and the g of x, okay? That this is for adding, subtracting, multiplying, and dividing. All right, these are your composite functions. So we're only going to do the values of the composite functions, but you could have also done it of any of the initial ones. So I could have said f plus g, which I think the homework's going to do. It is, for sure. Let's say it said f plus g of 2. I have two choices. One is find out what f plus g is from the original expressions, like 2x minus 3 plus 4 minus x squared. I could do that. Combine my like terms, simplify, whatever. And then plug 2 in. That's totally acceptable. The other way is to find f of 2 and then find g of 2 and add the values together at the end. I tend to recommend that one because you're getting rid of the variables from the beginning, okay? So plug them in and then add them. And that goes with adding, subtracting, multiplying, dividing. When it's a composite function, again, I can do the same thing. I could first find f of g here. I could take the g, I could plug it into the f. 2 times 4 minus x squared minus 3. I could simplify it, 8 minus 2x squared minus 3, which is 5 minus 2x squared. And then I can plug in -1. 5 minus 2 times -1 squared. 5 minus 2, which is 3. That's the first method. And I actually don't recommend it. I would do the second method. The second method is first find g of -1. So go into g and plug in the -1. And then take that answer and plug it in to the f. It is totally a coincidence that these are the same. Like what you get for g of -1 is the same as f of 3. That's totally a coincidence. These, no matter which method you do, should always be the same. Yeah, God bless you.
Do the minuses not cancel out for the 4 minus?
No, because you got to square it first. Yeah, exponent before subtraction. All right, so now go to B. What am I plugging 2 into? F. I'm going to find f of 2, which is 2 times 2 minus 3, 4 minus 3, which is 1. And then I'm going to find g of that, 4 minus 1 squared, which is 3. So go right to left on these. Questions on those? All right, so just to say it again, if you're doing a composite function like f of g, then you carry down the domain of the one on the right, the one you plug into first. You do not have to worry about the first one. So if it's f of g, I carry down g and then check for a new one. If it's g of f, I carry down f of x and then check for a new one. So A says f of g. I'm taking g and I'm going to check its domain. Is there a domain restriction on g? No. So I don't have to carry anything down. Then I plug it into f. Is there a domain restriction now? Yeah, what is it? It can't equal what?
X is greater than 2.
Not greater than.
Or it can't
It's in the denominator, right?
Can't equal 0.
It can't. So I'm looking at the composite function, which is 1 over x plus 3. What's the domain restriction on that? X can't equal negative 3. Remember, I don't worry about the one on the left. I worry about the one on the right, which was g, and then I worry about the new one. In B, it's g of f. Now I go to f. Is there a domain restriction on it? X can't equal 0. Then I put f into g. No, I put f into g, and I get 1 over x plus 3. And I check that. Is there a new restriction? It's the same it was. So my domain is negative infinity to 0 and 0 to positive infinity. So you're checking the one on the right. That carries down. Then you're checking the new combined one. If they are 2, you have to see where the overlap is. Questions on that one? Okay, so we did a value, we did an expression, now we're doing the graph. I know they're blurry, but you can see them overall. This is giving you 2 graphs. The one on the left is your f of x, the one on the right is your g of x. So if number 1 says find f plus g of 3, I'm not going to find the equations of those because they won't always be exact, and then plug in. I'm going to use the graphs. I'm going to find f of g, and I'm going to add to it g of 3. So f of 3 says use the graph on the left, go to where x is 3, and give the corresponding y, which would be what? 2. G of 3 says go to the g function, the one on the right, find the 3, give the corresponding y, which is 1. And then because it's f plus g, I add them, and I get 3, which is like the answer to 7 questions today. I don't know how that happened, but it did. Go to f over g of 2, and that means f of 2 over g of 2. I go back to the function on the left. What is f of 2? 0. What is g of 2? 2. And 0 over 2 is 0. Now we do the combination. So these are open dots. They're hard to read, but they're open dots. And this means find g of 2, and then take that answer and use it to find f of it. So what's g of 2? G's on the right. 2. What's f of 2? 0. So I first find g of 2, and then I replace that with it, and then I find f of that, which is just 0. Last one is g of f of 2. So first I go to f on the left. What's f of 2? 0, and I find g of 0, which is what? 4. So you have to do one and then the other, and the order obviously matters. Right to left on your composite functions. Questions? So we did adding, subtracting, multiplying, dividing composite with just expressions. We did it with values, and you did it with graphs. You're going to get tested on all 3, and that's what the homework is on. I am going to publish just the extra practice graphing portion of your test because I feel like that's where people feel the most like they need to spend time. It is not due. We will work on it again on Tuesday. Your 1-5 is due Tuesday. We will review one for the whole chapter Tuesday, Wednesday. But if you know you're struggling and it's stressing you out and you want to do some extra graphing practice, I will publish that portion of your test review, okay? But again, go 1-5 first. And then only if you are stressed out by not being prepared do you do the calculator part. If not, just wait till next week. We're going to review Tuesday and Wednesday.